Integer relations. Okay, we need to define what a relation is, and for us, a relation is going to be considered a set of ordered pairs. A set of ordered pairs. Okay, a relation is just a set of ordered pairs. So ordered pairs, notice the word pair. That means how many numbers are in a pair? Two. And then it's ordered. You got to have the right first number and then second number, right order. And so we're going to write it in this way normally, although later on it does change. You're going to have parenthesis, x, comma, y. So you're going to have an x value, comma, then the y value. They can both be whole numbers, integers, rational, positives, negatives, or they can be a mix of the numbers. So it's just one number, then another number. Okay, so here's my order. By the way, guys, I want you to realize that order does matter. So if I have this ordered pair right here, 6, comma 1, is that the same thing as 1, comma 6? No, they are not the same thing. They are not the same thing. You got to give it in the right order, because if not, you're giving me a different coordinate, a different point, and it doesn't belong in the same spot. Yes, sir. What was it up to?
Major.
What? Okay.
Like a homework grade?
Yeah, it's a homework grade. Yep. Yes, sir.
I don't get how 6. I don't get that, how they're not the same.
Okay, good, because they both had the same numbers, right? They have 6 and 1, but one had 6, then 1. The other one had 1, then 6. Think of it like this. In our interval notation, do you remember how the order mattered? You had to put like negative infinity, comma, a number, or positive infinity, and then the number before it. So if you switch those around, you're actually saying positive infinity is that way. Is that true? No, and negative infinity is that way? No, because it matters. Like you got to say negative infinity, positive infinity, and it's not the same thing. Yes, sir?
Could you go backwards?
Yeah. What I'm going to have you guys do in just a moment is you're going to write a set of ordered pairs, and then we're going to see what we know about those. Hi, so just waiting. Oh, we're good. All right, here's the set. We got 3, 6, and then 4, 8, 5, 10, and I'll write over here 6, 12. And actually, I gotta make sure I do this. No. Yes. Okay, there's a relationship among the numbers. Yes, and we'll look at that in just a bit. Do you guys notice there are braces at the beginning and end? Okay, do you remember set builder?
No.
Do you guys remember set builder was in braces? I hope you do, because you had a test on that.
Swivel.
So, oh, hi, Swivel. He does this a lot to you guys. All right, come back. Technology revolts against us. All right. Do you guys notice that I have my braces here? Okay, we're talking about a set, so we use set builder notation, boys. Set builder notation. And I have 4 ordered pairs, and these ordered pairs relate to one another in a special way. Now, we're just going to talk about 2 concepts. I think we did this last year, so it's not new. Sorry. But we talked about domain. We talked about range. Yeah, domain and range. This year, since it's review, it shouldn't be like, oh my goodness, what are we talking about? It should be like, oh yeah, I remember that. Do you guys remember what values the domain refers to? What does your domain refer to? X values. Okay, so here I'm going to put your domain refers the set of first values. And I'm doing that on purpose because I have to think about the future. Like, I have to think about geometry. I have to think about algebra 2. And so it's usually for us X, by the way, but it might be Y sometimes, or it might be R or A, but it's a set of first values. Okay, so looking at these ordered pairs, what are, and actually I'm going to have to put the range on another slide, what are the first values? What are the first values in every ordered pair? Alex?
3, 4, 5, 6.
Okay, so what we're going to do is we're going to say the domain is equal to, I have my brace. I'm going to put those numbers, 3, 4, 5, and 6, and put that in a set. That's my domain. Let me ask you this question. Ellie, looking at your domain, 3, 4, 5, 6, according to this set of ordered pairs, can 3.5 be a value in there? Can 3.5 be a value in there?
No.
No, you know why? Because it's not part of the ordered pairs. Okay, this is a limited set, limited to these 4 domain values. What do you think the range is going to be?
6, 8.
Sets, yeah, good. And then we're going to say the set of second values. Yep. Set of second values, and we're going to say R is equal to, and then what were those second values? Will?
6, 8, 10.
6, 8, 10, 12. It's a limited set because it's limited to just those 4 numbers, 6, 8, 10, 12. That's it. It can't be 9. It can't be -5. It can only be those numbers right there. Do you guys remember set builder? X is any number such that X is less than 5. Okay, that's any number less than 5. Any number out there less than 5. This is just saying it's only those numbers. Okay, you guys good on that? It's not too hard, right? Is this too easy?
No, it's actually way too hard.
All right, great. I like your feedback. That test was, I'm proud of that test. I like that test.
Did you actually change anything?
We're-
Actually change anything to make it harder?
Or did you just find a harder one?
Wait, time out. Swivel, record this. What are you trying to say, Justin? Like, it didn't change?
I don't think you changed.
No.
Josiah was easy?
Well, you're asking the wrong kid.
Will?
Asking
It was easy.
Is what?
Kind of.
Good
Very
answer.
hard for you.
Sophie?
Yeah,
Easy,
the
hard,
problems were different.
medium?
A few problems were.
It wasn't that bad. I was writing it and I was just like, they'll never get this.
12 is a little difficult.
Number 10. I think it should be a
I think I saw.
All right, guys, I'm going to step up my game on this next quiz, all right? Thank you for the feedback. All right, I'm glad you did well. If you feel good about it.
Let me guess, it was easy.
That is it. 4 ways to show relations.
Jared, we just gave Henry an upper hand on the test.
That's true, we did. Maybe I have to change some things for that. Okay, well, anyway, wow. Thank you, Will. 4 ways to show relations. We're going to look at those real quickly and then look at some examples. Again, this should be a review. The first way to show it is through a rule. I think, Will, you kind of brought up on that last set, which I'm going to write up here with that marker. Did it start with 4? Was it 4, 8?
No, it was 3, 6.
3, 6, thank you. All right. So I had 3, 6, 4, 8, 5, 10. Okay, and 6, 12. Okay. Now, with a rule, we're going to have to use, it's basically using an equation to come up with it. And lesson 4-3, I believe, is going to help us to find it. Now, listen to me right now. It is not always easy. Sometimes it's one thing you do to X to get to Y, and sometimes it's multiple things you have to do, and you have to think those through logically. But anyway, how do I go from X to Y in each order pair? So how do I go from here to here, from here to here, from here to here, or from here to here? Like, what do I do to that first number to get that second number? Multiply by 2. Okay, ready? Here it is. Ready? In order to get Y, I have to multiply X by 2. Is that true? Yeah. So I have to test that out. I'm just going to pick a random. I choose this one. All right. What's 2 times 5? 10. And I randomly pick this one. What's 2 times 4? Do all the ordered pairs fit this rule? So that is a valid rule for that function. And actually, I'm going to call it relation for now.
Did you say wise?
There is another way to say it. It would be like if you're trying to describe it in terms of x, you could say x equals half of y, right? X would equal half of that. So you could technically say it differently, but that's normally how we write it.
But aren't you just adding 1 to the x and then 2 to the y every time? Can you say it like that?
Can you describe it in one statement like that? Not so easily. This is the best way to write it.
X plus 1
And then you have to write a separate one.
is equal to y times
X plus 1 equals y.
x plus
No, because those are separate equations, separate
plus
things.
1 and then in parentheses
This is interesting.
2 is equal to y.
Yep.
That's right.
No. No, it's not. But that's okay. It's good to think it through. Number 2, we're going to use a table. Okay, we're going to use a table. This is one of the most common ways to look at a relation at the beginning. There were 4 values. So you have your x column and your y column. And on this one, guys, what were the ordered pairs? Can you give them to me real quick? Justin, give me the ordered pairs. 3, then 6, 4 and 8, 5 and 10, 6 and 12. That's how you would fill in that table. Okay, looking at this right here, guys, what's your domain? 3, 4, 5, and 6, the first column. What's your range? 6, 8, 10, 12. Can you pull out the domain and range from that? Hopefully you can. By the way, do you remember what I said about domain and range? Has to be written from, anyone remember this?
Smallest to greatest.
Smallest to largest, or least to greatest, yep. Okay, the other way to do it, number 3, is with a mapping. It's called a mapping. And I'm going to draw you a quick mapping right here. They used to call them circle mappings, but then my circles look a lot like ovals. So we don't call them circle mappings. What do you think is going to go in the first oval? What do you think is going to go in the first oval? Yes, sir?
3.
Okay, 3. Anything else? 3, 4, 5, 6. So put those in there, and you can do it vertically. Do it vertically, like a column. And then what do you think is going to go in the second one?
Well, yeah, 8, 10, 12.
Yep, and put it vertically as well.
I just put it in with Jess. She wants
Okay, great. Sounds good. So what was the first 3, 4, 5, 6? 3, 4, 5, and 6, and then 6, 8, 10, 12. Okay, so that's, you have your domain in the first oval and your range in the second oval, and then you get to, I love this part, especially when it gets all mixed around. Do you remember what you do between the two? Yeah, you draw lines. These are a pair. These are a pair. And that's reflected from our ordered pairs right here. So that's another way to show it. And the fourth way. Do you guys remember what a fourth way to do it? Hint, it's in your book. I'll do it over here. A graph, good. Drew, I think you asked me, are we going to do graphs? Kind of. Yeah, we're going to get to that eventually, but not so many graphs today. So we're not going to get that today yet. Do you guys remember how to graph x and y coordinates? Do you guys remember how to do that? Yeah. Can you try that? And here, I'm going to give you a little hint. So you're going to draw your coordinate plane. Now remember, isn't it more of a like a T? But why do I not worry too much about this region over here? Oh, sorry, raise your hand. Ader? Yeah, there's no negatives, so I don't really need to draw all this here. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. Just go out there. How far do you think I should go up?
12.
Why 12?
Because there's 12.
Yeah, 12 is my last y coordinate, so I'm gonna write this a little bit smaller. Or you can go by twos. 2, 4, 6, 8, 10, 12. All right, go ahead and give me those ordered pairs. And it has to be a certain shape. So if it's not a certain shape, something went wrong. And Nelson, do you remember your question about order? Order is going to matter. And I'll show you how it would change it if we decide to flip it around. By the way, guys, in my class that I'm taking, we're doing graphs, and you can see relationships between, for example, a student's motivation and a student's testing score. So the higher the motivation, what do you think the testing score, what happens to those testing scores? They tend to go up. Yep. And you can see a graph of it, and you're going to like, oh yeah, I can see it's going up while motivation goes up. I think there might be studies about like the more homework you have, the more happy you are in class. That's what I read.
I think it's the
I would
opposite.
say opposite, yeah.
Oh, oops. Got to read that research again. Oh, I read it backwards. No wonder. Okay, yeah. And that's actually a good point. You know that there's research saying one thing and there's other research saying the opposite thing? So you have to read them both. You got to read both sides and then say, all right, was their testing valid? Did they take the right people and test them out? And you're like, the right people? Like, what does that mean? How many of you remember the polls for the election, the presidential election? Do you guys remember what they were saying? That the current president was going to lose by a landslide. And then history shows that was the polls. The numbers were wrong. Okay, actually what happened was not the numbers were wrong. The numbers show that it's that the measuring was done incorrectly. The measuring was done. They were measuring the wrong people. So their graph looked like this. You know, it's positive toward one candidate, but in fact it was a little bit negative toward that same candidate in actuality. So you got to be careful with that. All right, let's go here, Dylan. Can you tell me where to put the first point, 3, 6?
Hang on. On the x-axis, right?
Yep.
You go 3.
1, 2, 3. Good. And how'd you know it's the x-axis? Because which number comes first? The x number. Good. 1, 2, 3. Good.
And then you count up 6 on the other.
1, 2, 3, 4, 5, 6.
Goes by 2.
Oh, thank you. That didn't happen. Okay. 1, 2, 3. So you went up by 2s. Okay, next point. Let's go with Daniel. 4, 8.
So you would go up 4.
Close.
Up 8.
Okay, you would go up 8 and to the right.
4.
So I'm going to go right first. 1, 2, 3, 4, and then 2, 4, 6, 8. Somewhere around there. Okay. Jack Hart. It's 5, 10.
So you're gonna go to the right 5.
1, 2, 3, 4, 5.
And up 10.
So I'm going to end up right here, right? And last one, Anna Grace, 6, 12.
You're going to go to the right 6 and up 12.
So 1, 2, 3, 4, 5, 6, and then right about here. Now, something that some of you are tempted to do, and I see it on your paper, is you connected it with a line. Should it be connected with a line? Yeah, so you're like, ugh. Should it be connected with a line? What do you think?
And that should be dotted, right?
Should be dotted, but why? I mean, we usually connect it with a line.
It could change.
So they're not, because it's not full on.
Okay, here, ready guys? Remember my set of ordered pairs? Could x be 3.5?
No.
Okay, so if you put a line, you're saying that 3.5, you're saying something's right there, but it's not there. There's nothing there. So it's just dots. Erase those little lines.
So it's like when we were doing the graphing last test, you would, like, instead of coloring it in, you would
Yeah, some are, yeah, good. That's it. Closed circles, open circles. Basically, you're saying there are closed circles where we put them, and there are an infinite number of open circles in between. And they're never going to create a space. That's good. That's a good point. Okay. Any questions on that? How many of you are ready to just do this on your own? You can determine the domain and range. All right, good. We have 25 of you, right? Okay, ready? I need 25 of you getting this right before we move on.
What about all the students?
26 of you, because I'm mean. No, 25 of you. Look at page 95. Please listen up. Page 95. And, I want you to get me the domain and range and the set of ordered pairs for the try these number 3. Whoa. Yeah, try these number 3. Sorry. I don't want to scare you on that.
So what are we?
Huh? What do you mean? Yeah, I'm throwing that in. Yep. So think about it, guys.
Domain, range.
The domain. So tell me what the domain is. Your answer should look like this.
And graph. Is it all of them?
Oh, you don't have to graph it. The domain, tell me what the numbers are. The range, tell me what the numbers are. And then give me the set of ordered pairs. So tell me, what are those ordered pairs?
Number 3.
There are 3 of them. Yeah, number 3. There are 3 of them. Just trying to help you out there.
Domain X.
Yep.
Oh, yeah.
The ghost is back. Okay, I'll give you another hint. How about that? Your domain is that first circle, and it's 0, and that's it. That's the only thing. It's only X value. It's the only domain value. It's a 0. But how many Y values do you have? 3. Sorry? I'm not saying. No
I don't
pressure.
know the order. Wait, never mind. Oh, I put them all in brackets.
Yeah, these are all, this lesson's about technicality. Just like the set builder and interval, technicalities. But Mr. A, it was kind of, nope. Just put that there.
What if it's close enough?
Then we will get close to 25, but not enough. Okay, I think most of you are done, if not finishing. Okay, I'm going to go with the next part. The range was A, B, and C. Now, normally go in alphabetical order. I hope that's not too absurd. I hate alphabetical order. Actually, Actually, I do hate alphabetical order because my last name started with A, and my teachers throughout elementary and middle school and high school even would assign by alphabetical order seating charts. So I was always front corner, which means I had to do this, and usually they were bigger rooms. I'm sitting there, the teacher's up there, and I'm having to do this the whole time. My neck is constantly crooked. And I would love to turn my table, but it was those desks that were attached to chairs that you can't just switch everything up.
But Miss Gray, if there was an Alberto, you wouldn't be
That is correct, because ALB comes before ALC. Thank you. All right, sorry. What do we? You got me so distracted that I don't even know where we're at right now. Oh yeah. Your order pairs are 0A, 0B, 0C.
Oh, I got that.
Do this on your desk. I don't want to show it up, but just put a thumbs up if you got it right, and then just put a fist down if you got it wrong. It's like an angry fist. Just don't hurt yourself. Oh, or my book. Sorry, I'm scanning.
If I forgot the brackets are on the bottom.
That's right, Mr. That's right.
Okay, so Jack, you can redeem yourself on this. Did anyone else?
No, that's right.
No. Did anyone else? Okay. Did I put those on for you at the beginning? I thought I did. Okay, but anyway, Jack, it's time to redeem yourself. Jack, no pressure. But I want you to do out loud. But not super loud, kind of quiet, but kind of like, you know what I'm saying? Okay.
Yeah, I get it.
I got to think of a problem, actually. Let's do this, Jack. I'll wait up for that because I'll give you some time to think. We're going to do one last problem. It's super easy. This is what we're going to do. Sometimes they're going to give us the rule. They're going to say, here's your rule. Okay, so that's what your rule looks like. By the way, we're going to get really good at looking at these equations, which I can't wait because it's going to help you out so many applications. But anyway, they're going to say, if the rule is y equals negative 4x minus 1, so if this is the rule, then tell me if 1, negative 3 belongs in that relation or that equation. So tell me if 1, negative 3 belongs, and you put true or false. But listen, I don't want the answer just yes, no, hey, I got it, because 50% chance I want that work. And here's how you show the work. All right, what does y equal according to that? What does x equal? So you just have to justify whether that's true or false. And you're like, well, it's whatever you say, but I need a justification.
Oh, I see. What if you were right?
Okay, that's the problem. See, I'm trying to help you out for quizzes and tests, and if you got the right answer, you said no, because that's true, it's not, but you said -3 equals -7. Well, on another problem, you might say no again, but it actually was true. So I'm trying to prep you up. I need to see these numbers right here. You will get it wrong, yes. I need the correct justification. And again, I'm prepping you up. All right, is that pretty easy to do? Okay.
No, that was just
Here's another problem with the same equation. Here's another problem with the same equation and a different ordered pair. I like these problems though, because this is going to be tough. They're going to give you 2k, okay?
okay.
Not 2k, anything else after it, or sports, unless it's the 49ers, 5-0. Following the Warriors trend. I mean, sorry. I'm getting distracted.
Literally, Jordan Sea's Yeah, how did D'Angelo Russell get dropped?
Are we talking preseason or the real thing? I'm sorry. All
Still got
right.
dropped. Bucket though.
They're going to ask you to do this. They're going to say, put that in there. They're going to put that in there and then solve for k. All right? It's a two-step problem. You're going to do this first, then solve for k. Okay? Totally right up on
Does
that.
it go
Okay.
X, Y?
It always goes xy. Okay, so ready? What does y equal?
K.
It equals k. What does x equal?
-9.
Sorry, x equals 2. They already told you what y equals and what x equals. I have to simplify and then solve for k.
I got it.
Okay. All right, what's -4 times 2? -8 minus 1. What does k equal? So you already solved for k. Yay.
So then you put -9.
Not
And where
-9.
Y is, and then you put, so it's equals. So, sure.
Yep. Yeah, you just want to find what k is. It's a two-step problem. Now, do you notice that it really wasn't that hard because they already gave you k? But they could have switched these up, and then you have to solve for k again. So be ready for that. All right. Do you want one of those? What time is it? What's my time here?
Time to go.
You're late. It's time.
123.
Time?
123.
It's
123.
It's 106.
Okay, great. Let's do this. One more problem. All right, here we go. Y equals -3x plus 4, and then the ordered pair is going to be h, comma 0. You need to tell me what h is. Solve for h. Oh, water. What a beautiful molecule.
Can I have some H2O?
You may after class.
Wait, is that
Uh,
H2O
or-
or H0?
Is hydrogen peroxide?
Mister, is it H0 or H0?
0. Yes, 0.
One go up to a bar and ask for some H2O. And the guy says, I'll have some H2O too. Yes, fine.
That is scary, William. I don't want to know this story anymore. Okay, anyway, you're going to put in, instead of x, you're going to put in h. H, yep. And instead of,
Zero.
yeah, you're going to put 0. All right, you're going to do this. So you guys are making me laugh. I never laugh. Okay, so I get 0 equals -3h plus 4. All right, does this tell me what h equals? No, it just tells me that 0 equals all that. So how do you solve for h? Subtract 4 from both sides. You're going to end up with -4 equals -3h. Then what do you do? -3. And you end up with h equals 4/3 or 1 1/3. 4/3 is better? Because you can use this later on very easily. If you turn it to a mixed number, you gotta usually turn it back into improper to keep working with it. So it's just something that's gonna help you out as you keep moving. We like improper now.
I made a careless error.
That's okay, as long as you figured it out. You guys are so good at this, I'm giving you your homework. 2 through 3. I think you got, I don't know. I think you guys are ready for a hard one. Right, Gracie? Tough one? She smiles, so that means she's ready. All right. Let's do
2 through 10.
2 through 18. Even. 89.90. Sir. Swivel. It was a pleasure talking about relations with you. All right, you got it? Good.